Wikipedia is an incredible resource, from winning an argument with facts and logic to learning about Jack Black. Not that guy, but the rat catcher and mole destroyer from Battersea, New England, during the middle of the 19th century. Given its coverage in literally anything there is to know, you could probably figure that the size of Wikipedia is pretty insane. In fact, here's this picture of how large Wikipedia would be if you were standing next to it with every page printed out. Recently, I was on the phone with a friend, and he said that if you start on any random article on Wikipedia, and you click the first link, and you continue clicking the first link of each article that you get to, eventually, you'll reach the philosophy article. Which got me thinking. I could make a Python script that sends requests to the Wikipedia API to get the links on the page, then take the first link to the next page and repeat until the page was philosophy. I could then build the structure of those pages to visualize the map. There's one problem. Actually, there's a couple of problems. One, the internet is really slow. Maybe I was doing something wrong, but I was getting a new request back in longer than a second. So if I retrieve a page at the speed of 1 second per request, 6.5 million articles would take 6.5 million seconds, or 75.2 days. Also, I don't want to get IP banned for accidentally making too many requests, because I really don't know what I'm doing. So then, I had this brilliant Wikipedia idea. What if I downloaded Wikipedia and processed all of it locally? This way I had control over all of the data. But as you might expect, one of the problems was just the sheer size of it. The entire compressed XML is about 20 gigabytes, and then when it's extracted, it's about 80 gigabytes. When I thought about it for the first time, I thought, hey, 80 gigabytes isn't even that much. It's like less than the size of GTA 5, and not even nearly the size of Warzone, which I think is almost 200 gigabytes now. It's actually incredible that all of the information on Wikipedia, which is like a vast map of all human understanding, can be stored on a single micro SD card smaller than your fingernail. Usually, when you process a file, your computer loads it into the random access memory, which is usually a good idea because RAM is fast and easily accessible to the CPU. My computer has 32 gigabytes of memory, which isn't terrible, but compared to the 80 gigabytes of Wikipedia that I have locally, that's just not enough. What it means is that I cannot just stuff all of Wikipedia onto the local memory. Like video games, I have to load it in chunks and then process those chunks as I go. Anyways, the overall idea was pretty simple. Wikipedia uses the square bracket notation to specify what it thinks are links. All I had to do was have the script look for double brackets, and then the whole process was super simple and painless. No issues. I've come to a certain point where there are only a couple of articles that don't work because they're weirdly formatted or something. However, it's not perfect by any means, so if you want to look at some atrociously written code and perhaps improve on it yourself, I've posted a GitHub and the link in the description below. Anyways, the script finishes iterating in about 30 minutes, at which point it spits out a JSON file. This new JSON file is only about 800 megabytes and contains only the name of the page and the page that it is directed to. Another script can then quickly search for the path of philosophy. And I mean, it's pretty fast. Besides loading the JSON, which takes about 15 seconds, the pathfinding is almost instant. Now we can get back to those cool graphs I mentioned earlier. I actually had some trouble finding the correct tools to be able to display millions of nodes, so I fell back onto reducing those number of nodes for display purposes. For example, this very useful cube of 7 million nodes lagged out my computer for a solid 5 minutes, so I had to write a recursive function to cut those nodes to about 10,000. When I could get them to load, the visualizations were pretty incredible. I used two tools for these visualizations. One was Gephi, I think, is what it's called, which is supposedly more powerful and can show direction, but was a lot harder to use and doesn't support hierarchy, so it's hard to show that philosophy is the central point of Wikipedia. The other was Graphia, which had almost no documentation, but was really nice to look at and easy to use. In Graphia, as you can see, philosophy is over here, with 15 nodes connected to it. Of those 15, 14 are pointed inwards towards philosophy, and 1 is pointed out. That one link pointed out actually circles back to philosophy. You can see by going through object philosophy, object of the mind, reality, and then to existence, the next is then philosophy. To show the interconnectedness of the entire graph is a little bit hard to prove, so I don't know how to use these tools that well. But taking this path out of philosophy kind of gives a big picture understanding. From philosophy, we can go to phenomenon, to mind, to mental state, to emotion, to feeling, to sentience, to consciousness, to reason, to logic, proposition, empirical evidence, scientific method, and finally to science. And if you zoom out from science, you can see how connected everything is to science, and how science then connects to philosophy. If you want to play with this data, you can also download Graphia, and I'll have the link to this node data so you can play with it if you want. And I mean, that's it. I'm kind of done with this project. I've been working on it nonstop for about 3 days and wrote this script literally as fast as possible. So if you don't understand something, it's probably my fault. And if you can't tell, I'm recording the audio and video from a closet because my computer has recently been making a lot of weird noises. I wonder why. Remember, links down below, comment if you have any questions, and peace.